This is the third video for March 31st, April 3rd, depending on if you're a B or A day. Here, the second video, we looked at how these logarithmic functions behave. In this next video, we're actually going to see how we can graph these logarithmic functions and determine their behavior. We'll go through three graphs together, and then I'm going to encourage you to try the other two or three. I can't remember how many else there are. But here, let's go ahead and graph this function. Similar to what we did last time, I'm going to encourage talking about a parent function. So if we want to talk about a parent function here, we want to talk about a parent function. Again, we want to think about stripping all of the transformations away from what's happening here. So our parent function, we could say, if we take away the plus 3 and the minus 1, would be log to the base 5 of x. So we're going to graph that function. I'm going to go out 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now we know that this function here, this parent function, will go through two key points based off of what's happening here. They will always go through 1, 0. All of our logarithmic parent functions will go through 1, 0. But they will also go through whatever our base is, they'll go to the point that base comma 1. So because our base here is 5, it will also go through 5 comma 1. So if we plot these points and then graph the function, it's going to go through 1 comma 0 and 1, 2, 3, 4, 5 comma 1. So as our function approaches this direction, it's going to look something like this. I should probably make that a little darker. But as it goes this direction, we also have this vertical asymptote on the y-axis. So as it goes this direction, it's going to approach the y-axis but never touch. Now from here, we can go ahead and graph our actual function. Based off our parent function here, now we know there's some certain transformations. Because we're subtracting 1 outside of our function, that tells us that we're going to go down 1. The plus 3 inside our function means we go to the left 3, so we do that to our points. We take our points down 1 and left 3. 1, 2, 3. Here, take it down 1, left 3. Down 1, 1, 2, 3. Now the question is, does our asymptote move? Does our asymptote move? And it does. Because it's a vertical asymptote, how we're going to move that is by moving it left or right. So because we moved our entire function to the left 3, our asymptote would also move to the left 3. So we now have this vertical asymptote here at negative 3, and our function ultimately is going to go through these 2 points after we moved them and get close to this asymptote. So it's going to look something along the lines of this. And we just said it, right? We just said that we have a vertical asymptote. Vertical asymptote. Again, if you need to pause at any moment, please do so. I want to move a little quick at a decent pace because of just timing of the video. Vertical asymptote at y equals negative 3. If we want to talk about domain and range, again, domain, we're talking about left to right. We're talking about our x values. So if we look at our function, what's the furthest left that our function can go? Well, here it's going to approach our asymptote. It's never going to cross our asymptote. So the furthest left it'll go is negative 3. How far right will it go? It will go on forever. It never touches at negative 3, so that's why the parentheses there. We can also talk about a range. It's going to go down forever in this direction, so it will head towards negative infinity. And as it goes out, it's also going up. It's slow, but it's going up, and so it is going towards infinity. A lot happening, right? I mean, but it's really interesting that we can graph a parent function, the same transformations apply to our usual functions, and then we could talk about our asymptotes, domain, and range. Really interesting if you think about it. Maybe not, but that's all right. Let's talk about this function. Chances are probably, well, we need to see the reflection. So here, if we talk about a parent function, let's do this. Talk about a parent function, then we could say f of x would equal log base 3 of x. Because it's log base 3 of x, then we know it's going to go through two main points. I will need to see those points on an assessment. Two key points. One, always 1, 0. Our log parent functions will always go through 1, 0. And the other one, because our base is 3 in this case, it will go through 3, 1. 3, 1. So it's going to go through those two key points. So we can go ahead and plot 1, 0, 3, 1. We have this vertical asymptote on the y-axis. And so our parent function looks like this. And we have two transformations. We're going to move to the right forward, but we also need to reflect, because of this negative, across x. Always do your reflections first. So if we because the negative is on the parent function, not inside our function, we will reflect across the x-axis. If we reflect across the x-axis, that point stays because it's on the x-axis. This point is going to be, instead of 3, 1, it'll be 3, -1. And so the reflected function, because we didn't move left to right or up or down, the asymptote stays. And then from here, we shift the entire function to the right forward. So these points, 1, 2, 3, 4, 1, 2, 3, 4. Our asymptote shifts to the right forward as well. And this would be our function. This is our function. We can talk about our asymptote, 1, 2, 3, 4. So we have a vertical asymptote at y equals 4. Our domain, how far left can it go? Well, it's going to go here, but it's never going to cross our new asymptote. So our domain would be 4 to infinity. And similar to our other functions here, our range, because it's going to continue to go down forever, but it's also going to go up forever, our range will be -infinity to infinity. I would encourage you to keep working on the other 4. Again, if you have questions, please bring those to me in class. We'll also take time to review April 10th and 11th. So if you have questions on those, please come ask me. I'll be happy to clarify any questions you might have.